We continue reading through the document, Electrical Safety Student Manual. Section 3, burns caused by electricity. Electrical shock causes severe burns. The most common shock-related non-fatal injury is a burn. Burns caused by electricity may be of three types: electrical burns, arc burns, and thermal contact burns. Electrical burns can result when a person touches electrical wiring or equipment that is used to maintain improperly. Typically, such burns occur on the hands. Electrical burns are one of the most serious injuries that you can receive. They need to be given immediate attention. Additionally, clothing may catch fire, and a thermal burn may result from the heat of the fire. Here you have a picture. Contact electrical burns. The knee on the left was energized, the one with the larger burn area, and the knee on the right, one with the smaller burn area, was grounded. That means likely the person was kneeling down and their left knee touched the energized conductor. Current would have passed through their knee, up their leg, to their groin, down to the right knee into the ground. Arc blast. These are explosive release of molten material from equipment caused by high amperage arc. What that means: the copper, aluminum, iron, or other material got extremely hot that they became liquid, and you have a splash of that material in the air. Arc blasts occur when powerful high amperage current arc through the air. Arcing is the luminous electrical discharge that occurs when high voltages exist across a gap between conductors and current through the air. This situation is often caused by equipment failure due to abuse or fatigue. Temperatures as high as 35,000 degrees Fahrenheit have been reached in an arc blast. Extremely hot, causing the metal to melt very quickly. A common example of arcing is the flash you sometimes see when you turn your light switch on and off. This is not dangerous because of the low voltage. When you're doing electric arc welding, you're making use of an electric arc in that case, assuming that you are working safely. Arcing. The luminous electrical discharge, that means bright electrical sparking through the air, that occurs when high voltages exist across a gap between conductors. There are three primary hazards associated with an arc blast. 1. Arcing gives off thermal radiation, that means heat and intense light, which can cause burns. Several factors affect the degree of injury, including skin color, area of skin exposed, and the type of color or the type of clothing worn. Proper clothing, work distances, and overcurrent protection can reduce the risk of such a burn. Proper clothing. You may this in some cases include eye protection, face shield, and overall gloves, safety boots, and thick jeans instead of tailored pants. Work distances, you maintain a certain distance away from wherever it is possible for an arc blast to occur. And overcurrent protection, in general, you're talking about a circuit breaker which will quickly detect the fault, electrical fault, and open the circuit. 2. The second primary hazard associated with an arc blast. A high voltage arc can produce a considerable pressure wave blast. A person 2 feet away from a 25,000 amp arc feels a force of about 480 pounds on the front of the body. In addition, such an explosion can cause serious ear damage and memory loss due to concussion. Sometimes the pressure wave throws the victim away from the arc blast. While this may reduce further exposure to the thermal energy, serious physical injury may result. The pressure wave can propel large objects over great distances. In some cases, the pressure wave has enough force to snap off the heads of steel bolts and knock over walls. 3. The third hazard. High voltage arc can also cause many of the copper and aluminum components in an electrical equipment to melt. These droplets of molten metal can be blasted great distances by the pressure wave. Although these droplets harden rapidly, they can still be hot enough to cause serious burns or cause ordinary clothing to catch fire, even if you are 10 feet away. You see in this picture, someone's clothing has caught fire. Let's look at this case. 5 technicians were performing preventative maintenance on an electrical system of a railroad maintenance facility. One of the technicians was assigned to clean the lower compartment of an electrical cabinet using cleaning fluid in an aerosol can. But he began to clean the upper compartment as well. The upper compartment was filled with live circuitry. When the cleaning spray contacted the live circuitry, a conductive path for the current was created. The current passed through the stream of fluid into the technician's arm and across his chest. The current caused a loud explosion. Co-workers found the victim with his clothes on fire. One worker put out the fire with an extinguisher and another pulled the victim away from the compartment with a plastic vacuum cleaner hose. So certainly would not want to use a metal rod or wire, which are conductors. Use a vacuum cleaner hose, which is an insulator, to move the victim away from the circuit. The paramedics responded in 5 minutes. Although the victim survived the shock, he died 24 hours later of burns. This death could have been prevented if the following precautions had been taken. Before doing electrical work, de-energize all circuits and equipment. Perform lockout, tagout, and test circuits and equipment to make sure that they are de-energized. The company should have trained the workers to perform their jobs safely. Proper personal protective equipment (PPE) should always be used. Never use aerosol spray cans around high voltage equipment. Thermal burns may result if an explosion occurs when electricity ignites an explosive mixture of material in the air. This ignition can result from the buildup of combustible vapors, gases, or dust. Occupational Safety and Health Administration (OSHA, OSHA) standards and National Fire Protection Association (NFPA) standards and other standards give precise safety requirements for the operation of electrical systems and equipment in such dangerous areas. Ignition can also be caused by overhead conductors or equipment, or by normal arcing at switch contacts or in circuit breakers. OSHA. This is the Occupational Safety and Health Administration. That's the federal agency in the U.S. Department of Labor that establishes and enforces workplace safety and health regulation. Look at electrical fires. Electricity is one of the most common causes of fires and thermal burns in homes and workplaces. Defective or misused electrical equipment is a major cause of electrical fire. If there is a small electrical fire, be sure to use only Class C or multi-use, that means ABC, fire extinguisher, or you might make the problem worse. All fire extinguishers are marked with letters that tell you the kinds of fire that they put out. Some extinguishers contain symbols too. The letters and symbols are explained below, including suggestions on how to remember them. You have Class A. Think A for ashes. And what form ashes? Materials such as wood and paper. And you see here the pieces of wood being burned. Then you have Class B. This symbol shows a container with a liquid. The liquid being poured out and is on fire. Think B for barrel. The barrel that contains flammable liquids. Then you have Class C. You see the plug here. To remember that, think C, circuits. C for circuits. That means it puts out electrical fires. Here are a couple of fire extinguishers at a work site. Can you tell what type of fires they put out? You see the slash across the bin and the paper, means it's not a Class A. This extinguisher can only be used on Class B and C fires. Right. This extinguisher can only be used on Class A and Class C fires. No Class B. Learn how to use fire extinguishers at work. However, do not try to put out fires unless you have received proper training. If you are not trained, the best thing you can do is evacuate. So, summary of section 3. Burns are the most common injury caused by electricity. The three types of burns are electrical burns, arc burns, and thermal contact burns. All fire extinguishers are marked with a letters which identifies the kind of fires they put out. Sometimes the label is marked with both a letter and a symbol. Be sure to read the label and use the appropriate extinguisher. we have reached the section on the first aid sheet. We will look at that in a separate video.